Everyone, welcome to my channel. So in this video I'm going to cover the solution to this question called time-based key value store. At the same time I'm going to go through the steps we should follow in the coding interview. So let's get started. So before we start the real content for today, I would really appreciate that if you can help subscribe to this channel. So let's start. Time-based key value store. Create a time-based key value store class time map that supports two operations, a set with three parameters, key, value, and the timestamp. And there is another API called get, has two parameters, key and timestamp. So for set, it is going to store the key value along with the timestamp, kind of like the big table. And for the get, it will return value such that set was called previously with timestamp underscore previous smaller equal to timestamp. If there are multiple such values, it will return the one with the largest timestamp prev, and if there are no values, it returns an empty string. Alright, so I think it's pretty clear. And let's see the notes. It says that all key value strings are lowercase. All key value strings have lengths in the range of 1 to 100, and the timestamp for all the time map.set operation are strictly increasing. So timestamp is between 1 to 10 million. Time map.set and time map.get functions will be called a total number of 120,000 times per task case. So it sounds pretty good. So what I can think of is, so for sure we need to have a map because we have the key and value, so it's pretty obvious we need to use a map. But since we have a timestamp and it is something like we also need to consider the timestamp. And it seems like we need to make sure the timestamp is in sorted order, and glad it says that the timestamp for all the set operations are strictly increasing. So what we could have is, without too much of the effort, so for example, we can have a map. The key is just a key, and the value is the timestamp with the value, something like a pair. And then for the set, it's just the normal set, and for get, what we could do is we could use binary search. So that could be one solution. Another easier one, I think, what we could do is we have a tree map. So we can have the key as the key of the map, and the value is the tree map. For the tree map, the key is the timestamp, value is the value. So that's pretty much two things I'm currently thinking of. So one is so solution one is we would have like a map. So the key is just the key, and value is a list of the entry with the timestamp, and value as just the value. So this is the first one. For the first one, the runtime is going to be, for the set, it is just going to be 01, and for get, it is going to be log n is the number of the entries for the corresponding key. So that one, yeah, so there is another one I can think of which would be easier from implementation wise. So we could have the key as the key of the map, and value is we can essentially have a tree map which is already sorted. Timestamp is as a key of a tree map, and value is just value. So the runtime is going to be the same actually. So having said that, maybe we can just start with solution one, which is going to save us some code, and also we don't need to do some specific implementation for the binary search. So let's get started. So what we have is we could have a map. Key is just a string, value is a tree map. So the value, so the key is here, it is integer, value is the string. So say this is the time map. This dot time map, or we can just save that this is equal to new hash map, something like this. And for set, what we could do is if if the time map that contains key, if it doesn't contain the key, then we will need to new a tree map. So I'll say like the tree map. It's like integer to string. Not really. We don't need to define the here. So you could just say time map dot put the key and the new tree map here, and here we will have time map dot get the key, and we are going to put so that got a key, and then we are going to put the timestamp, and I guess it's so I already put, yes, it's a key value, so this is timestamp and the value, so something like this. Yep. And for the get, we need to get the we should get the largest timestamp priv, which is smaller than the current timestamp. So what we have is we have the priv timestamp as equal to, so this is an integer. It would be something like a time map dot floor key to look for the key, and then this is the previous key. So if priv timestamp, if it is the non-pointer stuff, then you're just going to return. So what is going to return? So you're going to return empty stuff. Otherwise, we are going to return time map dot no. So this is time map dot well, this is a key and a timestamp. So I think I messed up. We need to first see if there is a corresponding key there. So if not time map dot contains key, if it doesn't contain the key, then we need to return empty string. Otherwise, it means we have the key and we need to like get the key and find the floor one, which is the timestamp. Right, this is a previous timestamp, and if this is a non-pointer, we just return empty string. Otherwise, we will say, okay, we will get the key and get the previous timestamp. So that's pretty much it. So for the testing part, we are just going to rely on this platform to help us to do the debugging work. It seems like it works. Let's run some other test cases. Alright, so let's do a submission. Alright, so it seems like we should be good. And that's it for this coding question. So if you have any question about the solution or about anything, feel free to leave some comments below. If you like this video, please help subscribe to the channel. I'll see you next time. Thanks for watching.